This is Where We Live on Connecticut Public Radio. I'm Lucy Nalpathanchel. The second planet from the sun has been called Earth's twin, yet Venus is often overlooked compared to other planets like Mars. With toxic clouds and crushing pressure, Venus is a notoriously hostile environment. But a recent discovery has scientists wondering about the possibility of life on Venus despite its hostile environment. Today, Where we listen back to my conversation in October with planetary geologist Martha Gilmore. She's a professor of geology, earth, and environmental sciences at Wesleyan University in Middletown and an expert on the planet Venus. Martha, welcome to the show.
Thank you, Lucy. I'm thrilled to be here.
We've been really excited about talking about Venus for the hour on Where We Live after all of the news and information that we're inundated with on a daily basis. It's nice to take a break sometimes and talk with someone like you, Martha. And so I guess it's been a while for many of our listeners who've studied the solar system in school. Can you give us a brief tour when we think about the planets out there and the different types of planets in our solar system?
Well, when I teach my introductory class, we divide the solar system into the rocky inner planets, like the one upon which we live, the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. And when we think about planets like our own, the terrestrial planets are our models. So Mercury, Venus, Earth, Mars are places that all have surfaces that we can access. We can look at the rocks, we can examine the atmospheres, and they're close, so we can get to them within a reasonable amount of time and explore them, as we have been doing over the last couple of decades. The outer planets are cool too, but as a geologist, what's more interesting to me about them is their moons, which have surfaces with water and activity. And so the places where we see the elements for life, which is liquid water and the elements that make up our bodies, organic compounds, seem to be in the inner solar system and in the moons of some of the outer planets.
You mentioned that our neighboring planets are easy to get to. So how close are we to, say, Venus and Mars?
Well, so Venus is the closest planet, actually. So it takes about 6 months to get there on a good day. And Mars, it takes a little longer. It takes about, I think the quickest route to Mars is about 8 months. Mars 2020 is on its way right now. And we launch at the opportunities that afford us the most efficient trajectory. So for Venus, that's every 13 months. For Mars, that's every 21 months. And so when it's time, when a window opens, it's wonderful if we can send a spacecraft to one of those bodies.
I mentioned earlier that Venus is often called Earth's twin, but there are some exceptional differences between Earth and Venus. Can you talk about those?
Oh, yeah. Well, that's what makes Venus so interesting. So really and amazingly, there's a simple relationship that governs how planets operate over time. And it has to do with their size. So imagine all the planets start out hot and then they cool off. And so the rate at which they cool is a function of size. I in class, I use this analogy. If you think about Thanksgiving dinner and you've got a big baked potato, and you've got a pea, that pea is going to cool off much faster than that baked potato, even though you really want that baked potato. It's not ready yet. It's not cool enough yet. And the amount of heat a planet holds drives its geologic activity. And geologic activity, volcanism, is the mechanism by which volatile elements, gases, water, get from the interior of a planet to the atmosphere. And it's a large part of what sustains the habitability of our own planet. So when we look around the solar system, the little moon cooled off a long time ago, Mercury as well. Mars had heat for a little while, which is why in its early history, it had rain and rivers and maybe oceans. But Venus, just by size alone, we expect to be as active, geologically active and warm as the Earth. And by that metric, we expect that it could be a place where we can sort of solve for that aspect of So we have two planets, the same size, the same amount of energy. One became Earth and one became Venus. And the answer to the question of why that happened is incredibly interesting, and helps us understand how habitable planets form and maintain their habitability.
So when we talk about Venus and the characteristics, so extreme heat, how hot are we talking, Martha?
Well, the surface is 450 degrees Celsius. So that is hot. And the reason the surface is so hot is because it has a very thick carbon dioxide atmosphere. And carbon dioxide is a greenhouse gas, and that elevates the temperature elevates the temperature of the surface. The clouds of Venus are not so hot, which is why they're an interesting place for potential astrobiology. But whatever happened in Venus's history, today it has this very thick atmosphere. But we don't think that Venus was like this all early in its history. And in fact, a lot of the work that has been done recently to think about Venus, how it evolved, how its climate changed over time, predicts that Venus should have been clement, should have had oceans for maybe a couple billion years. So if you were an alien who zoomed by the solar system 3 billion years ago, you would have seen 3 terrestrial planets, all of which had oceans: Earth, Mars, and Venus. And on Earth, at least, we know that life had already evolved and was starting to spread across the planet.
You're hearing Martha Gilmore again here on Where We Live. She's a planetary geologist and professor of geology, earth, and environmental sciences at Wesleyan University in Middletown. As we focus on Venus today, if you have a question, you can find us on Facebook and Twitter at Where We Live. There's also extreme, pressure on the surface. Can you talk a little bit about that, Martha?
Yeah, the thick atmosphere also increases the pressure. So the pressure is 90 times what you're feeling right now. So it is like being under a kilometer of water, actually, to be on the surface of Venus, and as far as the pressure is concerned. So it makes it a challenging environment to explore the Venus surface. But in fact, the first landing on the surface of another planet was on Venus. The Soviet Venera program landed a probe on Venus in the early 70s, and several more subsequently. So it's a feat of engineering, but it can be done.
So you mentioned this probe. How long did it last, Martha, when it landed?
Oh, it lasted an hour and a half before it died what we call a thermal death. But our technologies have advanced now such that we're pretty confident now that we can design a lander of that type that can last about 7 hours on the surface. And there's also work being done in high temperature electronics that can produce less sophisticated landing systems that could last for 120 days.
Oh, wow. We'll be talking more about maybe future missions to Venus a little bit later. But another reason that we're talking about Venus today is a discovery by scientists. Recently, researchers published a study saying that they detected a chemical called phosphine in the atmosphere of Venus. Why is this so interesting? And tell us more about phosphine.
Yes, well, I will tell you that many of us did not know anything about phosphine until this paper came out a couple of weeks ago. I'm like, what is phosphine? pH3. So it's pH3. And why phosphine is interesting is because there are several elements that are necessary for life: carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. And phosphorus is what our teeth are made out of. Phosphorus is a so is in the mineral form mostly. So most rocks that you pick up will have some minerals that have phosphorus in them. But to get a gas, and especially a gas that is reduced like this, so it has hydrogen, not oxygen, is requires it's a disequilibrium state. So life tends to put things in disequilibrium by taking the energy it needs from one place and utilizing it. So phosphine is made by life on Earth. It's also made in laboratory settings, but phosphine does not exist immediately when you put phosphine gas out on the Earth. It oxidizes and changes its composition. So to have phosphine gas on Earth means that, as far as we know, that life is active and abundant enough to produce this disequilibrium gas.
And so this idea that phosphine is in Venus's clouds, not necessarily proof of life, but life is one possible explanation for why it's there?
Yes. Well, this is the great thing about planetary science, because this observation was not made by geologists, it was made by astronomers who were attempting to test their techniques to look at the atmospheres of exoplanets by looking at Venus right next door. And when they looked at Venus, they saw the signature of phosphine. And then they spent a long time trying to figure out whether this signature was real. And part of the way that they can do that we look at signatures like this, is we look at all our libraries of the signatures of everything we know, every gas, in my case, every mineral. And we say, which thing can account for this particular observation? And to the best of our libraries, phosphine gas, it matches the observation that they made. So then that forces you to think, how do you get phosphine gas in the clouds of Venus? And we've known since the 60s, there was a paper by Morowitz and Carl Sagan, that Venus is shirt sleeve weather. Parts of the clouds of Venus are shirt sleeve weather. It's acidic. But there are lots of life forms on Earth that live in acidic environments. And there are the things that bugs like to eat are available in the Venus clouds. So it's been a hypothesis for a long time that the place on Venus that is most habitable today would be in the clouds. So maybe they are producing phosphine, or maybe we have to figure out all the ways that phosphine can be made without life.
That's really interesting. Again, Martha Gilmore is here on Where We Live, a planetary geologist and professor of geology, earth, and environmental sciences at Wesleyan University in Middletown, as we learn more about Venus today on the show. Can you talk about, again, this was really interesting when the news came out, but I've also read that, people are skeptical. They wonder if this is a false signal. Can you talk a little bit about that, Martha?
Yeah, well, I'm not an astronomer, so I'm relying on the authors and their reviewers to validate their technology. But it did impress me that they used two different telescopes to look at this spectral line. So they saw it in a sort of lesser telescope, and then they went to ALMA in Chile, which is one of the most powerful radar telescopes we have. It is the most powerful radar telescopes we have to re-examine the line, and it persisted. And it persisted over time and space. There's some variability in the presence and the strength of this line across the surface of the Venus cloud, I shouldn't say, across the cloud, the planet. So assuming that their techniques are good, which is my assumption, then the question for me more is, are there other things that we haven't discovered yet that could explain this observation? And that is always the challenge of planetary science. A corollary would be when we detected methane on Mars maybe a decade ago. So the first thing you could think is, oh, there are cows, on Mars, right? That's one explanation for methane. Cows emit a lot of methane, but in fact, it led us to discover and think about alternate pathways whereby you can produce methane gas without life. You can do it with water-rock interaction. And in the process, we learned about how methane forms in different environments. We learned about how rocks and water can do different things. And this will propel us to do the same for Venus. We are compelled to verify something as important as a life signature, to think about all the other ways that one could make phosphine without microbes, even though we don't know that right now.
This is Where We Live on Connecticut Public Radio. I'm Lucy Nalpathanchel, broadcasting remotely. Today we take a deep dive on Venus with Martha Gilmore, planetary geologist and professor of geology, earth and environmental sciences at Wesleyan University. She's an expert on Venus as we talk about the second planet from the sun. Do you have questions? You can find us on Facebook and Twitter at Where We Live. We'll be back after a short break. This is Where We Live on Connecticut Public Radio. I'm Lucy Nalpathanchel, broadcasting remotely. The planet Venus is well known because it's named after the Greek goddess of love. Venus also has been the focus of sci-fi writers, according to NASA, before scientists knew what was beneath its mysterious cloud cover. Could it be a hospitable planet? Today we know that's not the case, but scientists like my guest Martha Gilmore say there's a lot more we could learn from Venus. She's the principal investigator of a proposed NASA mission to Venus. We'll be talking about that in just a little bit. I wanted to talk with you more, Martha, about when we think about our space program and scientists studying our planets and the emphasis on looking for evidence of water on planets. And has that eclipsed more work on studying Venus when we think about just the last few decades?
Well, sure. Our assumption is that we are looking for life like our own. And for life on Earth, liquid water is required. So when we look out into the solar system, the Viking orbiter data and even the Mariner data before that for Mars revealed at the time, in the late 60s, that there were rivers on Mars. There was evidence of water flowing. And so that has that substantial evidence has driven the Mars program, and the fact that we can access the surface relatively easily. Nothing is easy in space science or going to another planet, that's for sure. But we can target we can look to the surface from orbit. We can look at the mineralogy from orbit, which tells us a lot about whether water was present to make the minerals that we see. And so the Mars program has allowed us to build upon the discoveries made by mission after mission to culminate in what Mars 2020 is doing now, which is the scientific community has figured out a place on Mars where a river was emptying into a lake for years, depositing stuff. And on Earth, that's a great place to go if you want to stick your hand in and grab a whole bunch of gooey microbes. So Mars 2020 is on its way to that carefully selected spot made possible by decades of spacecraft exploration, and will pick up some samples that we hope to go back to Mars and return to Earth to interrogate with all of our big machines that we can't miniaturize and send to another planet.
We'd mentioned this discovery of phosphine earlier in the show. Do you think that will bolster the public's interest in Venus and maybe make it a funding priority for future space missions, Martha?
I hope so. As somebody who is committed a lot of time thinking about going to Venus, I do think that life is something. The search for life is such a compelling idea for everybody. You, me, kids, Congress people. So that is part of what drives a motivation for the NASA program in general and one of its goals. But Venus, in and of itself, the phosphine is absolutely fantastic. But Venus is also important in terms of we are in an age where we can look across the galaxy, and I can tell my kids, and you can tell your kids, that there are planets around every star that they see, which is something that we didn't know when we were kids. And so as we start looking at these exoplanets, one of the things we're looking for are other Earths. And this comes back to the size. Venus and Earth are the same size. We expect when we look at these exosolar systems that Earth-sized planets are the best candidates for Earth-like planets. So we have an exoplanet right next door. We have Venus. It's the same size, and it is the only planet where we will be able to look at its atmosphere telescopically and also go there to verify the connection between what we see from telescopic data and what is actually going on in the clouds and near the surface.
I mentioned you're the principal investigator of a proposal to NASA for a mission to Venus. So give us a little history of the last time NASA, again, spent time studying Venus, and then what your mission hopes to do in the next several years.
Okay, so I want to be clear. This is not a proposed mission. This is a study that I was funded to do to design a flagship class mission to Venus. And this study, where we did design this gorgeous mission, is now being considered by the National Academies of Science, who set the agenda for what the priorities in planetary science should be and make a recommendation to NASA. So if the National Academy says this Venus flagship mission is the bee's knees, and this is what we should do, it makes that recommendation for NASA, then perhaps in the next decade, NASA will initiate a flagship class mission to Venus that will do all the wonderful things we want to do. But the last time the U.S. has been to Venus was the Magellan mission, which launched from the space shuttle in 1989. And the European Space Agency had an orbiter since then. The Japanese Akatsuki mission is there right now. But we have not, as a country, been to Venus in 20 years. And so there are two missions in contention right now in the Discovery program, which are the little missions that are led by PIs in the community, and one is a probe and one is an orbiter. And we hope that NASA will select one or both of those to go to Venus in the near term. And if the National Academies recommends a flagship class mission, then that would be also incredibly important to bolster our understanding of Venus after those missions go.
Can you explain more about what a flagship mission is?
Yes. I know, it's very Star Trek-y, isn't it? A flagship class mission is a mission that flies every decade or so. And the difference between it and smaller missions, for example, the Lucy mission and the Psyche mission, which are going to the asteroids, or the OSIRIS-REx mission, which is at the asteroid Bennu right now. Those missions are actually proposed by somebody from the community, and they're selected by NASA as after they are proposed. A flagship class is based on the recommendation of the National Academies, it's prescribed by NASA. So it's so large And by large, I mean in scale and also in dollars, billions of dollars, as opposed to less than $1 billion. That NASA runs it, and it's that's why it's a rarer event. It's a more costly and rare event. So Cassini mission to Saturn was a flagship class mission, for example, as was Galileo to Jupiter. So we're hoping that Venus will be the next flagship class mission selected by NASA to go.
Mm. You mentioned billions of dollars. When some Americans hear that, they wonder why spend this much for the space program. Tell us more about what you would tell them, the skeptics out there.
Well, lots of things cost billions of dollars. The Tappan Zee Bridge costs billions of dollars. I mean, this is expensive, and but the NASA budget, if you compare it to other budgets in the government, is quite modest. And we do a lot for the billions of dollars that we have by sending spacecraft across the solar system, doing earth science, doing aeronautics. The other A in NASA is aeronautics, looking at aircraft. So sure, it costs money, but that's what it costs to learn about our place in the solar system and to answer probably was one of the greatest questions of humanity, which is, are we alone in the universe?
You mentioned this study that you've been working on, but there's also finalists in the NASA's Discovery program. Tell us more about that and when it may be selected.
Oh goodness, yes. So yes, those were. So Da Vinci Plus is a mission that is a probe that would go down through the clouds of Venus toward the surface, collecting data all the way. And that's important because we have very little data below the Venus clouds. And on any planet, the interface between the surface and the atmosphere is where there's a lot of action, a lot of chemical action, a lot of that's where gases are coming out of the planet. So a probe is really necessary to go in and measure just the fundamental chemistry of the atmosphere of Venus. Where did Venus get its atmosphere? It's always surprising to me that we still don't understand as a community where Earth water came from. We don't know. We know that it's here. So it's very important to look to other planets to understand where the sources of water are in the inner solar system. The Veritas mission is an orbiter, which would take high resolution images of the surface of Venus. And both missions offer some spectroscopy, which can give us a hint of mineralogy, which has been so important to our understanding of Mars and Mercury and the moon. So our hope is that we will know whether we are selected in the spring, maybe March or April.
Something to look forward to.
Yes.
My guest today is Martha Gilmore, a planetary geologist and professor of geology, earth, and environmental sciences at Wesleyan University in Middletown, Connecticut. We'll continue our conversation just after a short break. First, I wanted to remind you, you're listening to Where We Live. I'm Lucy Nalpathanchel. If you enjoy learning about our state and hearing from Connecticut residents like Martha on Where We Live, please support this program and WNPR with a pledge. Here are two of my colleagues to tell you more. This is Where We Live on Connecticut Public Radio. I'm Lucy Nalpathanchel, broadcasting remotely. My guest today is Martha Gilmore. She's a planetary geologist and professor of geology, earth, and environmental sciences at Wesleyan University in Middletown, Connecticut. Martha, I should have asked how you got interested in studying the planets and geology.
Well, honestly, it was Cosmos, the show Cosmos, when I was a little kid, the one that Carl Sagan did. Now Neil deGrasse Tyson does. Because when I was little, the Voyager had just gone through the outer solar system, and to see those images coming back of world after world, it was just amazing to me. So I thought I wanted to be an astronomer, but then I learned as a teenager that there was this. I took a geology course actually, and went outside and looked at rocks, and I was like, "Oh, you can understand so much about the Earth by looking at a single rock." So somebody told me those things could be combined, and I've been very lucky to enter a field when it was relatively new that has expanded greatly because of all of the wonderful missions that we've been sending to throughout the solar system.
Hmm. We know across many STEM fields that representation is an issue. More women, more people of color are going into these fields, but many of the leadership and powerful researchers are still white men. Is this something that's similar in planetary sciences, Martha?
Yeah, I think it's the case everywhere. To be honest, but yes, it is. It is certainly. I shouldn't be. I'm laughing through my tears. It is certainly the case that there are fewer women, and definitely very few people of color in my field. In fact, our major conference, the Lunar and Planetary Science Conference, which I've gone to for 25 years. I was the only person of color there for a substantial portion of those years. And that is changing slowly, but in my mind, not slowly enough. So we suffer as many fields do with not having enough people throughout, not just at the top, but throughout the field to represent our society.
Hmm. You said that it's slowly changing. Tell us about what you think are the catalysts for some of that change that you're seeing, even though more needs to be done.
Yeah, I think the if you look across the field, the number of women, especially at the sort of the grads school and mid-career, is pretty much 50-50. I mean, I maybe a little less, but I have the opportunity now to work with a lot of women, which is something that wasn't the case always. So that has been getting better. Although, as you said, the number of women in senior level positions is still incredibly low. Um, Lucy Elkin-Tantons at ASU is the principal investigator for the Psyche mission,
Mm.
which is due to be launched soon to a metal asteroid, and she is the first female PI of a NASA mission ever. So we hope
Wow.
that this will change. One of the missions, the Venus missions, has a woman who's a PI, Sushma Kar at JPL, a geophysicist. But I think that's where we need to press hard, as well as bringing people in, but also making sure that women are in the top leadership positions across the field.
Mm. Your point about bringing people in, you mentioned you're a woman of color. So when you talk to your students or when you talk to even younger students in high school or middle school, what's your message to them? If they look around, these are children and students of color who are interested in your field, planetary sciences, but they don't see a lot of people like them. What would you tell them?
Yeah. Oh, this is hard. Well, I can say I'm here, and I can say find your allies. I mean, one of the nice things about Zooming all the time and being on the internet all the time is that you can actually meet with people with whom you would only see at a conference, maybe once a year or every other year. So finding those people and making it helps you feel that you are less alone, and that's very powerful for anybody who is in the position of being the only person of color in a situation. This position is not unique to planetary sciences. It's not unique to the sciences. A lot of students say, well, I could go to another field where there are more people of color. Yeah, well, a lot of this is a challenge that faces many of us in America. So my advice is that if you really love planetary science or geology, that you can try to remember that there's nothing intrinsically that prevents you, I'll tell my students, from being at the top of this field. Um, the infrastructure that holds us back is not of our own design, and it has nothing to do with our excellence. So it's hard to hold on to that, but that's where your friends come in and to support you, to get you where you need to be, which is a scientist.
Martha Gilmore, can you talk more when we think about the importance of diversity in the field, what we are losing when that's not the case?
Yeah, it's funny because scientists in particular always say that they are objective and, they don't see color and it's not an issue because they're studying physics or whatever. But the work of doing science is questioning your own assumptions. It's gathering input from a range of sources. It's listening, it's observing, and it's accepting some humility when you fail, as you do in science. So that methodology of science is actually the methodology of diversity. To get the answer, to get a good result in the scientific method requires making sure that you have views from a variety of sources and inputs. And that's why diversity enhances, not just science, it enhances any endeavor, because you are getting additional information from people. This is just a logistics, not just the ethics of it. That's another issue. But just logistically, if you want to solve a problem, you need to have people at the table who are not all like you. So I encourage my colleagues, I say, if you pursue the question of why all your faculty are white with the same amount of effort that you pursue the question of why your data are plotting over here and not over there, then you will make then you can make progress on this issue, which is so fraught and difficult to talk about it. Scientists have the tools already to look at the research, to think about it, to check their assumptions, to accept that our assumptions are maybe wrong. So we've done this before. It's a matter of realizing that diversity is essential to all aspects of our job and our lives.
Through your career, when you're in a room and there are other women scientists as part of the conversation, how does that conversation change compared to if you're in a room with a lot of male counterparts?
It's wonderful. So I had the experience earlier this year before COVID. I went to Goddard Space Flight Center with members of my science team for the Venus flagship mission. And the members, our team was at least half women. And the members who attended that time for my team were all women. So 5 women walk into the room, scientists, and the room was not all male engineers. It had women engineers and had women of color engineers. And it's a perceptible, it's a perceptible difference in how you feel in terms of whether you belong in that space, whether you'll be listened to in that space, the method of communications in that space. And so it's enabling to be in a room where you're not the only person who is the only woman or the only person of color. And it helps us do great work. So that's why we need more of us.
We just have a couple of minutes left, Martha. When we think about science education in our country, how to spark that interest in young people, what are some of your suggestions so that we can have more scientists in studying, and especially in your field?
Well, I think that pre-COVID, there are many ways to access. We have wonderful museums in Connecticut, and attached to them as museums behind the scenes are scientists many of us who are very happy to talk about what we do, or to even have students participate. Even I've had high school students in my lab. I talk to little ones, but if you just ask Most scientists will talk your ear off about what they do and are so happy to just show you what they do. So ask a scientist, ask somebody at a museum if you're interested. Just one question can become a path to an opportunity. It can become a path to a career.
Thanks to Martha Gilmore, planetary geologist and professor of geology, earth, and environmental sciences at Wesleyan University in Middletown, Connecticut. Today's show is produced by Carmen Baskoff. I'm Lucy Nalpathanchel. We talk about a lot of things on Where We Live, from Venus to Connecticut history and politics, too. If you appreciate what you learn each day on Where We Live, please support this program and WNPR with a pledge. Here's how.